I am Larry Hatcher. This is Psych 302, Computer Applications and Data Analysis. And in this video, we're going to look at part 2 of Lecture Notes, Chapter 125, ANOVA with two within subject factors. Remember that this chapter was divided across 2 class meetings. Last week, we covered pages 1 through 33, which was part 1, showed you how to do the analysis in Jamovi. And this week, we're going to cover pages 33 through 47. This is part 2, in which you will learn how to make sense of the results produced by Jamovi and how to summarize those results in correct APA style. Note to my students, as always, remember, you don't need to download the data set or perform the analyses described in these notes. Simply use these notes as a guide when you're completing your exercise, which will involve a different data set. Let's refresh our memory on ANOVA with two within subject factors before we start talking about the results. I'm looking at page 3 of this set of lecture notes. We got way past page 3 last time. I just want to refresh your memory on the basic research design. You're conducting research on what's the best way to put together an e-reader that college students can use to read textbooks, read regular books, and read articles and such. You conducted a simple investigation in which your participants was a group of 10 college students. So we have this entry, all 10 participants. Your sample consisted of exactly 10 college students. You manipulated 2 independent variables. One independent variable, factor A, was screen resolution. At one point in time, a given participant would use a screen reader that had a high resolution screen. And at a different point in time, the same participant would use an e-reader that had a low resolution screen. After using one type of screen or the other, they would complete a form with which they would rate reading enjoyment. Reading enjoyment scores could range from 1 to 100. Higher values indicated greater reading enjoyment. So one of your independent variables was screen resolution. Your second independent variable, factor B, was screen size. At one point in time, a given participant used an e-reader with a 6-inch screen. Different point in time, the same participant used an e-reader with a 10-inch screen. At another point in time, they used a 12-inch screen. After using, for example, a high-resolution 6-inch screen for 2 weeks, they rated their perceived reading enjoyment. Then the same participant used a 10-inch screen with high resolution. Used that for 2 weeks, at the end of which they rated their reading enjoyment. This continued with each participant using every possible combination of these 2 factors for 2 weeks. This was randomized, and the study required 12 weeks because a given participant used a given combination of independent variables for 2 weeks, and they were exposed to all of the possible combinations. So 6 times 2 is equal to 12. Your entire study required 12-week participation of your participants. So this was page 3, where I reviewed the basic research design. In this investigation, there's any number of effects that you might have predicted and investigated. And I indicated that for this chapter, we're going to focus only on interaction effects. I'm on page 6 of the lecture notes. We got way past page 6 last time, but I want to refresh your memory. You learned about interpreting main effects in a previous chapter that dealt with between subject research design. Now we're looking at within subject research design, and we're going to learn about a different kind of an effect, an interaction effect. Based on a review of the literature, you predicted that there'd be a significant and substantial interaction between your 2 factors. And on page 7, at the top page 7, I have a figure that illustrates your prediction of what the results would be. With this figure, one of your factors, screen size, is represented as 3 points on the horizontal axis: 6-inch screen, 10-inch screen, 12-inch screen. Your other independent variable, screen resolution, is represented by 2 different lines within the figure. Solid line represents when they're using high resolution screen. Dashed line represents when they're using a low resolution screen. You predicted that screen size would have an effect on reading enjoyment. If you looked at the people that are using a low resolution screen, you predicted that people, when they have a 12-inch device, they would experience more reading enjoyment compared to when they're using a 10-inch device, which would be higher levels of reading enjoyment compared to when they're using a 6-inch device. So you predicted, yes, the size of the screen will have an effect on reading enjoyment, but you predicted you'd see that relationship only when they're using a low resolution screen. You predicted that there'd be no relationship between screen size and reading enjoyment when they're using a high resolution screen. That's illustrated by the solid line at the top. Notice when they're using a high resolution screen, there's no difference between the reading enjoyment they report when using a 12-inch screen versus a 10-inch screen versus a 6-inch screen. This is the interaction effect that you predicted. Now, this is just a hypothesis. We don't know whether you're going to get it or not, but this is the outcome that you're hoping to get, be supportive of your research hypothesis. So that was page 6. Now we can go to the actual starting point for today's lecture, and the starting point is going to be page 33 or thereabouts. Last week, you learned how to request descriptive statistics that would help you determine whether your assumptions were met. Last week, you learned how to request the two-way ANOVA that would allow you to determine whether there's support for your research hypothesis. And last week, we left off in this vicinity. We were on page 33 last week, where I showed how to complete the last part of the analysis options panel for the analysis, the part of the panel where you're requesting estimated marginal means. We went over the details of how to set up the analysis options panel for repeated measures ANOVA so that Jamovi would perform the two-way ANOVA with two within subject factors. And toward the end of our meeting last week, we were at the bottom of page 33, and we had these statements. Enough already. We've now requested ANOVA with two within subject factors, test of sphericity, post hoc test, tables of means, plots of means. You can now begin work on Jamovi Exercise 125.01, ANOVA two within factors. For today, you'll do only task 1, performing the analysis. You did that last week. You did part 1, which consisted of task 1 last week. We are now at this week, and we're going to do part 2. Part 2 of this exercise is going to involve interpreting the results produced by Jamovi and summarizing those results in APA style. But before you can do part 2 of that exercise, you have to do part 2 of these lecture notes, which will explain how to make sense of the Jamovi results and how to summarize things in APA style. So this is where this week's lecture actually begins. I'm on page 34 of the lecture notes. The section is headed Interpreting Results from the Analysis. So page 34, Interpreting Results. Halfway down the page, we have the null hypothesis you're investigating. Null hypothesis for a two-way interaction. Earlier section of this chapter indicated that the current statistical procedure can be used to investigate possible main effect for factor A, possible main effect for factor B, possible interaction between factor A and factor B. To provide some focus, let's assume we are most interested in the possible interaction effect. Here is the research hypothesis of interest. There'll be an interaction between screen size and screen resolution such that there'll be a relatively strong positive relationship between screen size and reading enjoyment when using a low resolution screen, but B, there'll be no relationship between screen size and reading enjoyment when using a high resolution screen. That was the prediction illustrated by the figure that I showed you just a minute or so ago. What about null hypothesis? When we do null hypothesis significance test, we have to state a null hypothesis and then see if the sample data allows us to reject it. So we have this. We can revise the statistical null hypothesis slightly so that it refers specifically to the variables included in the current analysis. Here's an example, null hypothesis. There is no resolution by size interaction in determining reading enjoyment scores in the population. Remember, null hypothesis is the one that the researcher almost always hopes to reject. And by the end of the analysis, we hope we can reject this null hypothesis, which says there's no interaction. We're on page 35 now. General trend of the results. Typically, you'll begin by looking at mean scores on the dependent variable to see if they display the general trend that you had predicted in your hypothesis. So there's a number of places in the Jamovi output that you can look at sample means to see what the general trend is. First of all, you had requested the Jamovi descriptives procedure compute a bunch of descriptive statistics, among which are sample means. Okay, when people use a low resolution 6-inch screen, their mean reading enjoyment score was 36.10. When they used the low resolution 10-inch screen, mean score was 50.50. Okay, these means are useful. Maybe we'll wind up reporting them in our write-up, but at this point it's kind of difficult to look at these means in the form of a table and make sense of them. Is there another possibility? On page 36, we have basically the same means in a table that's headed estimated marginal means, screen size by resolution. These are the same means that I referred to earlier, but again, they're in the form of a table, and it's hard to look at numbers in a table and understand what exactly they represent. What you want to do is look at these means illustrated in a figure. So on page 36, about halfway down, now we have the results that we want. Finally, most importantly, the means are also illustrated in a line graph created by estimated marginal means. It's presented below. And yes, this should look very familiar. This is the graph created by Jamovi, but it's very similar to the graph that I had presented in stating a research hypothesis, isn't it? One of our factors is screen size, 6-inch versus 10-inch versus 12-inch. One of our factors is resolution. The blue line represents the scores obtained when people use the low resolution screen. Is that orange? The orange line represents the scores they displayed when they use the high resolution screen. It looks familiar. Isn't this pretty much the pattern that I had illustrated when I stated my research hypothesis a minute ago? If we focus on just the sloping blue line, which represents the low resolution condition, there appears to be a positive relationship between screen size and enjoyment. As the screen size becomes larger, reading enjoyment scores become higher. And yes, that's what we see with the blue line. When people are using low resolution screen, the bigger the screen, the more their reading enjoyment. However, where's my however? Here it is. On the other hand, if we focus on just the flat gold line, okay, that was gold, not orange. If we focus instead on the flat gold line, which represents the high resolution condition, there does not appear to be any relationship between screen size and enjoyment. As screen size becomes larger, enjoyment scores do not appear to change in any systematic way. This might indicate that we have a statistically significant interaction effect, although we won't know for sure until we review the F statistic, the p-value, and the effect index for the interaction, to be presented a bit later. So far, so good. We have positive relationship when folks are using low resolution screen. Essentially no relationship when they're using a high resolution screen. Maybe we're going to have that statistically significant interaction effect we want. We shall see. Let's scroll down. I'm on page 38 now. One of the things we have to worry about when we do within subjects ANOVA is a special assumption that we don't have to worry about when we do between subjects ANOVA, and that special assumption is sphericity. Page 38, about halfway down, sphericity tests provided by Jamovi. Preceding requests produced a table headed Tests of Sphericity in the Jamovi results panel. A table is presented below, And below the table, I talk about the contents of that table. At this point, we're most interested in the interaction effect, so we're going to focus on the bottom row of the table, which is headed resolution by screen size. This top row gives us tests pertaining to sphericity for the resolution main effect. The next row, tests of sphericity pertaining to the screen size main effect. And then the last row is the one we care about. Now, it's resolution star screen size. That is the row that provides information about the resolution by screen size interaction. The column headed Mauchly's W, which is this first column identified with callout number 1, provides the W statistic, which tests the null hypothesis that the current sample data was drawn from a population that displays sphericity. Column headed P, which I have callout number 2, provides the obtained probability value for that statistic. If this obtained p-value is greater than the selected alpha criterion, typically 0.05, many researchers take it as evidence that the sphericity assumption is satisfied. Well, let's take a look at that. Here's the interaction term. The p-value for Mauchly's criterion is 0.764. That's a lot bigger than 0.05. So we didn't reject the null hypothesis because it's non-significant. That means we're okay. That means we have satisfied the assumption of sphericity. Now, there's additional statistics in this table. The next paragraph refers to one of them. The column headed greenhouse geyser contains the obtained value of the greenhouse geyser epsilon statistic. Depending on whether this Mauchly's p-value had been significant or not, it may have been necessary to go on and also interpret the greenhouse geyser epsilon statistic. But since our Mauchly's statistic was non-significant, we don't have to go that far. We don't need to look at the greenhouse geyser epsilon statistic, at least according to the criteria we're using. It is described on page 39. To keep things simple, this chapter will follow the strategy recommended by Navarro and Foxcroft. This strategy involves reviewing just 2 statistics from the table: Mauchly's test for sphericity and the greenhouse geyser epsilon statistic, which is what we just looked at. Here's the recommended approach. If the obtained p-value for Mauchly's test is greater than 0.05, you can assume that your data satisfy the assumption of sphericity. This outcome means you should report the unadjusted f-test. This is the f-test we requested by selecting none in the Jamovi assumptions check panel. That is something that you'll recall from last week. Actually, we don't need to go to the additional bullet points. We can see that p-value for Mauchly's criterion for the interaction is 0.764. That's bigger than 0.05. That means it's non-significant. That means we're okay. We have satisfied the assumption of sphericity. What do I say next on page 39? At this point, we're most interested in the interaction effect, and this means we'll focus on the bottom row of the preceding table, the one headed resolution by screen size. This row indicates that for the interaction, Mauchly's W statistic was 0.93, and its corresponding p-value was 0.764. That's the p-value that I just referred to. This p-value is larger than the alpha criterion of 0.05, so we'll tentatively conclude that the sphericity assumption is satisfied, and we will therefore interpret the unadjusted f-test for the interaction term, as will be demonstrated in an upcoming section. Okay, that makes things simple. We're going to look at the unadjusted f-test when deciding whether we have a significant interaction or not. I continue. I am still on page 39. Results from the omnibus significance test. In the preceding section, we decided that the f-test that's most appropriate for our data set is the unadjusted f-test. We requested this when we checked the box none in the Jamovi assumptions check panel. The ANOVA summary table created by this request is presented below. The assumption checks panel allows us to decide what kind of omnibus significance tests we want to review. Last week, I had known ahead of time that the sphericity assumption was going to be satisfied, and so I direct you to check none. We don't need any correction. And checking none caused Jamovi to report the following repeated measures ANOVA table. This is on page 40, repeated measures ANOVA. These are the results that we're going to look at in deciding whether our interaction effect is significant. Let's scroll down a bit. I'm on page 40 now. Preceding Jamovi output consists of two tables. Upper table is headed within subject effects. This part of the table will be of greatest interest to us because it provides results related to our studies within subject's effects. And what are we talking about? Well, Jamovi gave us two tables, one of which is headed within subject effects, one of which is headed between subject effects. We care about the upper table, the one headed within subject effects. The subsection headed resolution provides results for the omnibus main effect for screen resolution. So if we were interested in determining whether we have a main effect for screen resolution, we would look at the results in this first row of statistics. The subsection headed screen size provides results for the omnibus main effect for screen size. So if we were interested in the main effect for screen size, we would look at the statistics in this second row. And finally, subsection headed resolution star screen size provides results for the interaction effect. We said earlier that that's what we're going to be most interested in. So we hope that we see results in this row that tells us we have a statistically significant and also meaningful interaction. Let's continue. I'm on page 41, toward the top of page 41. We have a section headed, is the interaction effect statistically significant? One of the first decisions we will make involves determining whether the interaction effect is significant. If it is, we'll focus primarily on interpreting this interaction. We'll ignore the main effects for resolution, main effect for screen size, even if they happen to be statistically significant. You've heard me say before that this is a rule of thumb that researchers typically follow. Sometimes there's exceptions to this rule, but the general rule of thumb is that if the interaction between two factors is significant, focus on interpreting the interaction. Don't focus on interpreting the main effects for either of those factors, even if they happen to be statistically significant. There's exceptions to that rule, but that's the general rule. I continue on page 41. F statistic for this interaction effect appears in the Jamovi results presented earlier at the location where the row headed resolution star screen size intersects with column headed F. There we can see that the obtained value is F is equal to 5.04. Probability value for this F statistic appears below the heading P. There we can see that the obtained p-value is 0.018. This is smaller than our standard alpha criterion of 0.05, indicating we may reject the statistical null hypothesis. Instead, we may conclude that the interaction between screen resolution and screen size is statistically significant. What was he looking at? Back on page 40 with the ANOVA summary table, we're looking at the row headed resolution by screen size. Under the heading F, our obtained F statistic is 5.04. Okay, that's bigger than an F statistic of 1.0, which we would expect if there was no effect at all. But is it enough bigger than 1.0 that we can say it's statistically significant? Find out, we look in the column headed P. The p-value, the probability value for this F statistic is 0.018. That's smaller than 0.05, but smaller than our standard criterion. So yes, it is statistically significant. We can tell the world that we have a statistically significant resolution by screen size interaction. And I'm on page 41 again. We have gone over the bit about whether it was statistically significant. As you know, sometimes results are statistically significant, but not terribly meaningful. To find out whether it's meaningful or not, among other things, we'll look at an index of effect size. So, did this interaction produce a substantial index of effect size? The effect index produced by this interaction appears in the Jamovi results table at the location where the row-headed resolution star screen size intersects with a column-headed partial eta squared. That's our symbol for partial eta squared. There we can see that the obtained value is 0.36. According to Cohen's criteria, this is a large effect. What Cohen's criteria? I summarized Cohen's criteria in the preceding paragraph. So anyhow, this paragraph says partial eta squared is 0.36. Where did that come from? Let's go back to page 40, looking at the ANOVA summary table. In the row for the interaction effect, this third row, under the heading partial eta squared, the value for partial eta squared is 0.36. According to Cohen's criteria, that is a big index of effect size. So our interaction effect is not only statistically significant, but it is large. It is of large enough magnitude that we can call it large according to Cohen's criteria. I return to page 41. We continue reporting the F-test for the interaction effect. We'll report the results of the significance test for the interaction effect following a format similar to the format used in previous chapters. Here's the relevant sentence from the research report. In writing our results up, we'll say the following. The ANOVA indicated that the interaction between screen resolution and screen size was statistically significant. F with 2 and 18 degrees of freedom is 5.04. Mean square error is 163.74. P is equal to 0.018. The statistics appearing at the end of this sentence are presented according to the conventions of APA style. They are diagrammed below. I took these statistics at the end of this sentence, reproduced it here, and I have labeled each of the parts. Here's our symbol for the F statistic. Here's our degrees of freedom. Here's our obtained F value. You've seen this kind of diagramming done in previous chapters. What do I have to say about it? On page 42. Each of the preceding statistics were taken from the ANOVA summary table produced by Jamovi. That table is once again reproduced below, this time with call-out numbers in different locations. Here's our same ANOVA summary table that we saw before, but with call-out numbers for other statistics. All the statistics in the preceding excerpt were taken from the last two rows of the repeated measures ANOVA output. That is the row headed resolution star screen size. It presents statistics related to the interaction effect itself. Symbol for the F statistic in degrees of freedom. The preceding excerpt from the research article begins with a symbol F, followed by the degrees of freedom. That's F2 and 18 degrees freedom, which in my excerpt was right here. F with 2 and 18 degrees freedom. Two values within parentheses are the degrees of freedom for the F test. These values appear in the Jamovi ANOVA summary table presented below the heading DF. So go to the column headed DF. DF is degrees freedom, where this column intersects with the row headed resolution by screen size. We see the 2 and 18 degrees freedom. That is where my 2 and 18 degrees freedom came from. We return to page 42. Obtained value for the F statistic. This value appears in the Jamovi ANOVA summary table at the location where the column headed F intersects with the row headed resolution star screen size. For the current analysis, it was 5.04. We have already seen this in the ANOVA summary table. Below the heading F, to the right of the heading resolution by screen size, the obtained F statistic for the interaction was 5.04. Mean square error. Next item in my summary is the mean square error. In the ANOVA summary table created by Jamovi, this statistic appears at the location where the column headed mean square intersects with the row headed residual. In statistics, residual means pretty much the same thing as error, hence mean square error. There we can see the mean square error for this analysis is 163.74. What is he talking about? In the column headed mean square, to the right of the heading residual, the mean square error is 163.74, and that is why I reported the mean square error is 163.74 in my write-up. We continue. Page 43, at the top of page 43, this is probably the first thing that you are going to look at when you perform your analysis with Jamovi. It's probably the first thing your reader is going to look at when they're reading your write-up, and that is the obtained p-value. The obtained probability value for the f-test appears at the location where the column-headed p intersects with the row-headed resolution star screen size. Table shows the obtained probability value is 0.018. This is smaller than the alpha criterion we had selected, 0.05, so we can reject the statistical null hypothesis. Where did that come from? Page 42, ANOVA summary table, below the heading P, where that column intersects with resolution by screen size. This p-value, 0.018, is the p-value associated with this F statistic. It's less than 0.05, so yeah, our resolution by screen size interaction is statistically significant. We continue. I'm still on page 43. All right, so our interaction effect was statistically significant, but did it represent a large effect size? To find out, we need to look at an index of effect size. Omnibus index of effect size. For our analysis, we chose to report an omnibus index of effect size called partial eta squared, and this is the symbol for it, to help readers understand the magnitude of the interaction between the two independent variables. In the ANOVA summary table created by Jamovi, this statistic appears at the location where the column-headed partial eta squared intersects with the row-headed resolution by screen size. There we can see the obtained value is 0.36. Yes, we looked at that just a moment ago on page 42. Here's our symbol, partial eta squared. Partial eta squared for the resolution by screen size interaction is 0.36. That is a large effect, according to Jacob Cohen. We continue to page 44. The complete summary of results from the research manuscript. We've been reviewing the results of our analyses one piece at a time, but at last it's time to put it all together. Below is the complete summary of results from the ANOVA, just so you have a sense of what it looks like all put together as it would appear in a research manuscript. We have a table that presents means and standard errors and confidence intervals for the cell means. We have the text in which I write up the results for the omnibus effects, among other things. We have a graph that illustrates the nature of the interaction. By the way, whenever you are doing factorial ANOVA, two-way ANOVA like this, and you have a significant interaction, it is fairly standard that you just about have to illustrate this interaction in a graph. It's very difficult for readers to grasp the meaning of the interaction unless you draw a graph like this or some kind of graph that illustrates the nature of the interaction effect. Page 45, we have a section headed Checklist, Reporting ANOVA with two within subject factors. This chapter showed how to perform ANOVA with two within subject factors using Jamovi's descriptives and repeated measures ANOVA procedures. Here's a summary of the major steps involved in performing the analysis and writing up the results. Because so many steps are involved and because it can be so tedious, at the end of the chapter, I put together this checklist in which everything is put in one spot. And so at the bottom, page 46, your marching orders. Now complete your work, a Jamovi Exercise 125.01 ANOVA, two within factors. For today, you'll complete task 2, which is taking multiple choice quiz, and task 3, uploading your Jamovi file in Canvas assignments. The file you upload is exactly the same Jamovi file that you created last week when you performed the analysis, assuming you performed the analysis as you were supposed to last week. Task 2 is where most of your points will be. It's taking the multiple choice quiz. Remember that there's a study guide included in the exercise that'll help you get ready for that multiple choice quiz. So those are the tasks to perform, but that's not the end of the chapter. What else appears here? We have a note. You do not need to complete the activities described in the chapter appendix below. It is simply provided so that students will have instructions for creating data sets from scratch if they conduct within subject experiments in the future. So this is here for those students who might need it with future research projects. We have gone through the material relevant to part 2 of our current set of lecture notes. Lecture notes that we have been reviewing this week and last are lecture notes chapter 125, ANOVA with 2 within subjects factors.